Hello everyone, and in last lecture we discussed about the second basic signal, which was the ramp signal, and we also discussed few examples on a ramp signal. In today's session we will discuss the third basic signal, which is the impulse signal, and is given by del of t. So del of t is called the impulse signal. So we have plotted the del of t signal with respect to time axis. The value of del of t is 1 at t is equals to 0, and it is 0 elsewhere. So we can simply write this signal mathematically, del of t as del of t is 1 for t is equals to 1, and the signal is 0 when t is not equal to 0. So it is a very simple signal, impulse signal. It only exists for t is equals to 0. Now let us see the time shifted del of t impulse signal. Now the signal is del of t minus a. So if you put t minus a is equal to 0, you will get t is equals to a. So the impulse is present at t is equals to a with value 1. So we can write down the signal del of t minus a mathematically as del of t minus a is equals to 1 and t is equals to a, and the signal is 0 for t is not equal to a. And we already know del of t minus a is a right-sided signal and it is delayed signal. Earlier, the signal or the impulse was at t is equals to 0. Now, the impulse is at t is equals to a, hence it is a delayed signal. Similarly, we can have the left shifted signal as del of t plus a. If you put t plus a is equal to 0, you will get t is equals to minus a. Hence, the impulse is present at t is equals to minus a with the value 1. So we can mathematically write del of t plus a, its value is 1 for t is equals to minus a, and the value is 0 for t is not equal to minus 1. So del of t plus a is a left shifted signal, hence we can say it is an advanced signal. Now with this basic understanding of del of t, let us find the Laplace transform of del of t with its some examples. So the Laplace transform of del of t is 1, and it is very interesting. The Laplace transform, the Fourier transform, the Z transform, everything of del of t is 1. Since we will be discussing only about Laplace transform, the Laplace transform of del of t is 1. So now let us solve some examples on impulse signals of Laplace transform. We have the question, find the Laplace transform of del of t minus 2. So let us find the solution for this question. It is very easy question. We can give a name to the signal as r of t. So r of t is nothing but del of t minus 2. Now since there is a shifting, or to be specific, there is a time shifting, we can use the time shifting property, and we know x of t minus t naught time shifting in t domain results in exponential in s domain with same sign. So x of t minus t naught, its Laplace is e raised to minus s t naught. So using this time shifting property, we can find the Laplace transform of del of t minus 2. We have seen the Laplace transform of del of t is 1. So Laplace transform of del of t minus 2 will be, we know the Laplace of del of t is 1, so I can write this as 1 into, using the time shifting property, t minus 2. If you compare this t minus 2 with x of t minus t naught, we can write it is e raised to minus 2s. So I can write the Laplace transform of r of t is r of s, and it is nothing but e raised to minus 2s. The Laplace transform of del of t minus 2 is e raised to minus 2s. Now let us go to the next question. Next question is find the Laplace transform of tan del of t plus 5. So again we can use the time shifting property to find the solution of this question. So I can write tan del of t plus 5. We have to find its Laplace transform. Now we know the Laplace transform of del of t is 1. Then the Laplace transform of tan del of t will be 10 as it is using the linearity property, and Laplace transform of del of t will be 1. So the Laplace transform of tan del t will be 10. So the Laplace transform of tan del of t plus 5 . Now here it is time shifting t plus 5. Again, if you compare this equation with x of t minus t naught, you will get it is 10 exponential e raised to plus 5s. So the Laplace transform of 10 del of t plus 5 is nothing but 10 e raised to 5s. So these were some important and basic Laplace transforms of an impulse signal del of t. As I told you earlier also, we are discussing only the points which we will be requiring in our subject control system. So this was about the impulse signal del of t. Our next signal will be the parabolic signal. So see you in the next lecture.